Hello everyone. I wanted to take a second to go over problem 8 because I realize that the algorithm as described here is just maybe a bit annoying to read through the text. Textual descriptions of algorithms are a little bit tough sometimes. I tried to provide this picture of the result, but I'd like to actually walk you through the algorithm too. Before I do that though, let me actually explain to you why I'm giving you this problem a little more. So actually I took out a problem from a similar problem set that I made before that was very mathematical, but maybe not as pedagogical as I had hoped. And I replaced it with something I thought was very practical. I do not think this problem is harder than the one I'm replacing it with, but it does require a little bit more background. But with the background, I hope you get something more useful. And in fact, I've actually given you problems like this before. So in fact, the very first DFA that I gave you in the formal DFA section was an example of this. So I was saying, give me a DFA that accepts all binary strings that contain 0, 0, 1. Well, there's your string containment right there. So if I was going along and I see 0, 0, 0, 0, 0, 0, 0, I keep repeating this and I have part of the prefix there until I see the 1. So I don't have to start all over again. I can actually remember, okay, I've seen a couple zeros, so stay here until you see 1. And actually, even on the last problem set, this problem 2, 1, some people were asking on Discord too, like, what is this? I can't come up with a simple description. Well, it turns out, I don't know if you got this or not, but if I draw this out in kind of a similar layout to how problem 8 is laid out, I can see that this actually is also the same thing. The only difference is I flipped the accept states, and I guess this was the start state here. But yeah, I flipped which states accept and which ones don't. So technically I'm looking at the complement of the language of strings that contain, in this case, 1, 0, 1, 0. But it's cool because it kind of keeps track of prefixes, so I don't have to start over every time. If I see a 1, 0, 1, I'm waiting to see a 1, 0, 1, 0. But if I see a 1, 0, 1, and then I see a 1, well, I don't have to jump all the way back to the beginning. I know at least I can get credit for that 1 and then try again. So what I'm giving you here is a tool to just, given a particular pattern, construct these automatically. So you could actually even go back and try these problems. If you gave it 0, 0, 1 with the binary alphabet, and you run that through, JFlap should give you something that looks a lot like this. If you run through 1, 0, 1, 0 through your program with the binary alphabet, JFlap should give you something exactly like this, except the status of whether a state accepts will be flipped, because I have just one more little thing I threw in here to make it the complement. Okay, but let me show you the algorithm that I'm giving you to construct this. So I have it here in text, but I think it'd help if I show it to you as a drawing in Inkscape. So the pattern that I'm interested in building a DFA for in this example that I gave you is A, B, A, B, A, C. Okay? So A, B, A, this is the second one, B, A, C. So these are the states. So, first thing I'm going to do is set up the states, and my convention here that I'm expecting you to do is, hang on, A, B, A, B, A, C. The convention that I'm expecting you to do with naming states is which character is it, underscore which index it is. And so that helps us to disambiguate characters that are the same, but that occur at different places in the sequence. So the first step is just to set up the states. So that's fine. The next step is to set up the direct arrows. So like when I was looking at this JFlap a moment ago, I have these direct arrows. If I go 1, 0, 1, 0, that's my pattern, right? 1, 0, 1, 0. So I'm gonna set up these direct arrows in sequence that respect my pattern. So from the start, I'm going to put an arrow to A0 if I see an A. Okay. So let's see, object fill and stroke. Let's make that a proper arrow here. So that's what will happen if I see an A. If I'm at this state and I see a B, then I will go to the B1 state. And if I'm here and I see a B, I'll go to the B2 state. Oh, I'm sorry. If I'm here and I see an A, I will go to the A2 state. The A is the next one I'm supposed to see. If I'm here and I see a B, I will go to the B state. And let me just pause this for a second and finish. Okay, so here's all the direct arrows. Now, the other thing I need to do is I need to finish, so my alphabet actually here consists of 3 characters. So whatever your alphabet is, you're going to need an arrow for each character coming out of every state because this is a DFA, right? So eventually I'm going to need to fill in all the arrows in every state. Right now, each one only has 1 arrow coming out of it. To start with, I can at least finish the arrows at the beginning here. So I can say, okay, I know that I have to start with an A. So if I don't start with an A, then I need to just stay at the start and kind of wait a little bit. So both the B and the C in this example are going to have a loop back to the start. So that's important. Okay, so this is how you should start out with all these direct arrows. Now the algorithm to fill in the rest of them. So we're good with start now, right? We at least have that one completely finished. But now we're going to fill in the rest of these in sequence. And so what I'm going to do is basically, the algorithm is chop off the first character of this prefix of the pattern. Then add on the character of the arrow I'm figuring out. Okay. That's what I wrote for you in the directions. I'll explain why we're doing that in a second. Okay, after that, what we need to do is simulate the DFA that we've built so far on the resulting string. Okay, so if I'm at this state here, then I've seen an A. So actually, if I chop off that character, I'm left with nothing. So if I look at the A arrow here, it's like chopping off A, and then chopping off the first character here, which leaves me with the empty string, and then adding on an A to go back. And I'll start at the beginning with an A. I have that arrow A takes me here. So actually, the first one's a little bit harder to explain. Once we get started, I think it'll become more clear. But anyway, we end up having a self loop here if I follow this procedure. And then if I see a B, well, okay. Again, I chop off the first character here. I end up with the empty string. I add on a B. So going back to the beginning and starting with a B, I actually get a self loop there. So the arrow actually goes back to the start if I see a B. Okay. So let me go ahead and do that. All right. So now I'm finished all the arrows in A0. So in the first element in the sequence after start. Let me go on to B1 now. So B1, okay, look at the alphabet. I got A, B, C. I've already got my A arrow. What about the B arrow? So, okay, by the time I've gotten here, I have the string AB, right? So what I'm telling you to do is, okay, if I chop off the B here, so if I'm considering the B arrow, then I chop off the first character, which is an A, and then I add on the B to the end. So I'm considering here BB. So let's go back to the beginning and see where BB goes. Well, that's just a self loop right back to the start. So if I'm at B1 and I see a B, I'm supposed to just go right back to the start. On the other hand, if I see an A, so if I see an A, well, then I chop off the first character, and I'm left with the B, but then I add on this. Oh, sorry, I've already done A. If I see a C, let's do the C. If I see a C, chop off the first character. I'm left with the B. I add the C on the end. Now I start back at the beginning and I put BC through. B gives me self loop, C gives me self loop. So actually C also takes me back there. So both the B and the C take me back to the start from B1. Okay. Let's keep going here. So when I'm at A2, I've seen ABA. So let's follow this recipe that I had. So let me chop off the first character. And I need to know the arrow for A and the arrow for C. I know the arrow for B. I've already filled that in. So the arrow for A, let's see. So I'm saying chop off the A here. And then we're left with BA and then a plus A on the end. So BA, BAA. So start back at the beginning. B takes me to start. And then I see an A. And then I see an A. And I end up there. Okay, so I can shortcut that whole thing and say, okay, an A would actually just take me back here. Oops. Okay, so the A arrow coming out of there takes me back to A0. And then the other one we need to look at is C. In that case, again, we chop off the first character of ABA. We get BA, and then we put the C on the end. So BAC, we go B, A, and C. Where did C take us? Maybe I didn't finish C here before, I think I forgot, but C should take us back to the beginning here as well, from A0. Okay, so C actually takes us down to the beginning again. So we see a C, we have to start over. Okay, let's keep going here. So now I have my arrows A, B, and C out of A2. What about B3? So by the time I get to B3, I've seen A, B, A, B. I know what the A arrow is supposed to do coming out of that, but I don't know what the B arrow is supposed to do. So let's consider the B arrow. So we chop off the first character here. We're left with BAB. And we're saying, okay, what happens if you tack a B on the end? So let's go back to the beginning and see. So I see B, A, B, B. So actually that takes me back to the start. So B takes me back to the start here. Okay, and I also need to figure out C. So if I'm looking at C here, chop the first character off, left with BAB, tack C on the end, go back to the beginning, and see B, A, B, C. Actually, again, I go back to the start. So B and C both bring me back to the start there. Okay, let's keep going. We're almost done, actually. And then I can check and see if I actually agreed with what the program came up with. So, okay, I'm at A4. So what I've seen now is A, B, A, B, A. And so I know the C arrow here. Let's look at the B. Let's look at the A arrow first, I guess. So for the A arrow coming out of A4, chop off the first character. I'm left with B, A, B, A. And then I tack an A on the end. And so I go back to the beginning, I look here, I see, okay, B is the self loop there, A, B, A, A. So I end up back at A0. So let me check that one more time. B, A, B, A, A. Yep. Okay, so that'll take me back to A0. What if I was considering a B coming out of A4? So chop off the first character, I get B, A, B, A, tack a B on the end. So now I have B, A, B, A, B. So B, A, B, A, B. This is probably the best we've done so far. Actually, we only have to back up one place here. So B, A, B, A, B takes us back to B3. So if I see a B, then I can go back to B3. and pick up where I left off. All right, and just one more to do here, and then I think I have all the states. So finally, when we get to the end, we've seen the whole sequence. Now, if this, if we were going to stop the first time we saw the sequence, this would just be kind of, all the arrows would go right back here. But this is not like an ordinary DFA. We actually don't really have an except state. It's more like this state, we kind of want to know every time that we hit the state, because we want to find every subset. So I actually want to keep going here. And I want to figure out the 3 arrows that would come out of this. And if I could say, okay, well, maybe I can reuse some of the work and see another substring that's a slight offset there. So let's just follow the same recipe. This time, though, I have to fill out all 3 arrows. So let's look at A first. So if I look at A, chop off the first character. The rest is BA, BAC. And let me tack an A on the end. Okay, so let's see. So B, BA, BAC. Actually, sorry, BA, BACA. So BA, BACA. So that takes us back to A0, right? That's where we end up if we go and follow that pattern from the beginning. Okay, so that's where the A takes us. What about the B? Okay, well, the B is going to take us, same thing. We remove the first character, we've got BA, BAC, and we're supposed to tack a B on the end. Okay, so let's look at this. B, A, B, A, C, and B, which is a self loop here. So a B is actually going to take us back to the start. So we got that. So the B is going to take us back. Okay, and then finally we're going to have the C. So instead of tacking the B on the end, I'm going to tack on a C. And I have BA, BACC. So I get B, A, B, A, C, C. So that also takes me back to the start. Now here's the moment of truth. So this should be it. Now I've filled in all the arrows. And so the question is, do I actually agree with what I had on the website? Let's see. So can I get these both side by side here? Okay, I see that. Did I get all the arrows? So yeah, we got the BC, we got the A coming from the C5 back over there. We've got the nice little A-B situation happening here. We got the B up here, yep. I think I got it. Okay, cool. So that was following the algorithm out in gory detail, myself by hand. But this is actually not too bad if you do a loop. So once you have the direct arrows set up after step 2, and then you have the arrows set up from the start state to itself, then you just have to walk through state by state and figure out which strings you're going to send through the DFA. Because the idea is, like when I was here, let's say I made it up to this far, right? So I got to A, B, A, B, A. And then, I saw an A, right? Which is not the direct path there. Okay, so I know I'm not going to follow the direct path, which means that I couldn't have included this entire sequence. So the reason this actually works is, it's okay, well, I couldn't have, I'm not going to progress any further than 4 characters at that point. So let me just chop off that one, and I'll see what happens when I tack on the A, see how far I can actually get with this particular prefix, which is the suffix of the pattern I'm searching for. So that's why the algorithm works, and this is kind of the foundation behind the Knuth-Morris-Pratt algorithm that I was telling you that you can actually look at for extra credit. Okay, so I hope that helps. Let me know if you have any other questions. I don't think the code will be too bad once you know what you're doing, but it was a little bit hard for me to explain what you're doing. Just to help also, I showed you here's what the dictionary should look like on that particular example. This is how you're going to specify the dictionaries, just sort of like the way we define things formally and the way that I've shown you an example so far. So the keys are tuples of states and characters, and then the values are the states that you're supposed to go to. So this is the dictionary representation of the picture that we just drew. And so you could print that out, and you should see that. That should help you debug too. But then this is like the icing on the cake. I made some code to help you make these diagrams, and if you want to really check your work, you can go back and check these other examples, like this formal description here, and then the very first DFA they gave you here, and any example you can come up with, just try it out, see what the DFA looks like for that particular prefix. Okay, so have fun with this, and then in the next assignment we're gonna take this even a step further and make something called grep, which is recognizing something called regular expressions, which is even more. Here we have to match an exact sequence, and in the next assignment you're going to match a fuzzy sequence. So I'll talk more about that next week.